which I told you yesterday to write at the top of your paper. Did you?
Yeah.
Okay. So, the first one is 1 plus r over n, keep the n times t. This works for anything compounded, monthly, whatever. Compounded continuously is per. This is when you see the continuously. Okay? Now, we can't solve these algebraically because we don't use logs yet. We haven't used logs yet. But we're solving them graphically, the same way we did yesterday's. You've got a y1, a y2, and you can see where they intersect. Some of them you just have to plug them in. You don't need your y equal. For instance, did we do this one in class? We did the first two in class? Okay, so this one you're plugging in. This says compound continuously. So continuously doesn't give me any number, so I know I need to use per. And to plug it in, all your money should be rounded to 2 decimal positions. I'll just quickly go over these two. This one, determine when. I'm looking for time. When an investment of $2,300 accumulates to a value of $4,150, so it's earned some interest being compounded at a rate of 9% compounded quarterly. We plug everything in. Your N is your compound quarterly. Your R is your rate. Flip it to a decimal. This is your unknown, your T. My time is unknown. Now, plug this right into your Y1, right into your Y2. Part of the problem is your window. But think this out. What's nice when you have a Y2, there's your maximum. Here's your Y max. Your Y is going to go from 0 to make it 5,000. Remember, your window is not your exact measurement. It just gives you a window to look at this. Your X, I don't know. I don't know how many years this is going to take. I'll go 0 to 20, 0 to 10. If I don't see them intersect, change the X value. The Y, has to be good because you got an X. Everybody okay with this? Can you graph these? No, kinda? Okay, I'll pick another one because we did that one yesterday, but I'll pick another one to graph. Okay, determine when. Here's another one. Determine when this happens. I'm looking for time. I'm compounding monthly. I invest a value of $1,500. I get a maximum value of $3,750. I earn 8%. So again, there's your Y. Your Y is going from 0 to 4,000. My X, I don't know, 0 to 20. See how many years this takes me. Now, let's graph this. So I'm going to go to my Y equals. You're going to have to help me out because I don't know the numbers. 1,500. 1,500. Mr. Santa Cruz said he would come and fix my board today. Well, we'll see. One. All right, what was the interest rate? 0.08?
Mm-hmm. This one.
Yes, what did I miss?
Shouldn't it be divided by 12 instead of 9?
Shouldn't be what?
Divided by 12.
Yes, it should be divided by. Thank you. And what was this monthly times how many years?
No, we're finding T.
We're finding T. Okay. All right, I'm going to go up and change that divide there. This is annoying. I'm sorry, but we'll get to the bottom of this soon. Okay, now watch. We're investing and we're going to make $3,750. Okay, think this out. Again, your window of your Y has to go from 0 to 4,000. Your X, I don't know how many years this is going to take. It's not a really big jump, but it's a good enough jump. So I'm going to make it 20 years. If I make it 10, I can always go change it if I don't see them intersect. I'll make this 4,000, just slightly more than. Slightly more than that. There's my interest accumulating here over time. And here's where I reach my max. And then I just do an intersect. Second, trace, number 5. You got to hit it 3 times. That's your X. It's going to take 11.492 years for that to reach that value that I wanted to get. Okay? And think this out reasonably. The ones you probably got stuck with was the ones that had the finding the rate. That was trickier. I went through this part yesterday when it doubles, right? The 2 to 1. Kind of. No matter what you invest, pick any amount to invest. If I want to invest $500, when it doubles, what does it become? 1,000. So here's my perk. 500 e to the RT. However, my interest rate times my t. This belongs to this. That exponent only belongs to the e. Therefore, I can divide by 500. So I get 2 to 1. Doubling, 2 to 1. If I invest $1, I make 2. If I invest $2, I make 4. I'm always 2 to 1. A tripling, I'm 3 to 1. Can you use 500 and 1,000? You absolutely can. Then you just change your windows. If you use 2 to 1, do a zoom 6 and start from the 0 zeros. It's much easier. But you can use any amount that you want in there as long as you double it. So you're looking for your time again, y1, y2, and look for when they cross. If you use this little number for y, make y go from 0 to 5. 0 to 10 is fine. Go back to zoom 6 and set them at zeros.
On the test, you're gonna have the
formula?
Yeah.
No. You were supposed to know that from algebra 2. Both of those. We use both of those in algebra 2. Okay, this one was tricky. This is the tricky one. Where's your paper? Okay, take it out. This one's tricky. We set it up, we're compounding annually, so we're only dividing by 1. And do you have to divide by 1? No. I just use the same formula all the way through. So I don't have to divide by 1. I'm looking for this time my rate. That's my variable. So in my y1, I'm putting 1580, 1 plus my x to the 8. In my y2, I'm putting 3000. Now think about your window for a second. What's your y go to? 0 to what? How much do I want to make? 3,000 maximum. So make my y go to 3,500. My window is just telling me where I'm going to see this at. My x. My x is not time. My x is a rate. When we take the rate of 9%, what do we put in your calculator? 0.09. So if you go from 0 to 10, you're never going to see this. So you really should go from 0 to 1. Even 0 to 0.5, you'll never see a 50% one anyway. But 0 to 1 would be absolutely fine. If you went from 0 to 10 and all you saw was this line, it's still there. If you do an intersect, it will still do it. It will still find it. So the rate is the harder one to find. I've already paid for a second. I'm going to put this on the calculator and show you what I'm talking about. Okay. Doesn't like this part of my board. Okay, watch guys. I'm going to set my window. I'm going to set my window x 0 to 10 for now. I want to show you something. This, I could leave this at 4,000. That's fine. Here's my intersect line. It's intersected to my graph. But I don't really see my graph, but watch. Second, intersect. It finds it. It's there. That graph is there. But you set your x from 0 to 10. That rate is only 0.08. It's a less, wait, hang on one second. It's a less than 1. So it's like riding right along this y-axis, but your calculator can still find it. Now the better way to do this is this. Go from 0 to 1 and graph it. Now you see your graph, and now you can see where it intersects. But it's still there. Question. Who did I ask to wait?
Would you be able to find it if you were in a Zoom 6?
It would still be able to find it in a Zoom 6. However, you want to make it be only quadrant 1 because in your real situation, that's where your data is. It's never negatives. So always start your mins to 0. It just narrows down what you have to look at as well. Okay? All right. Did I give you back your paper? All right. I don't know why I did that. All right. Let's see if we can just get through this part. Where am I? I don't even know where I am. Okay. All right. Okay, same for this one when you had to find the rate. Same exact problem. The only thing we changed is the compounding. So instead of divide by 1, divide by 12. Okay? Set your y. There's your maximum. Set your y from 0 to 40,000. Set your x from 0 to 1. If you set it from 0 to 10, you can still do the intersect. It's still there. Your calculator knows it's there.
If you're going to be like, exact on the rates,
You have to do 3 decimals. 3 decimals. Rule of thumb for any precalc, 3 decimals.
if you have like 0, 0.102.
Or if you move the decimal, that's fine. How much time is required for an investment to double? Double, 2 to 1. Time, T, that's what I'm looking for. You're compounding quarterly. And that, again, any amount you want in here for your principal. 100, 200. Just make sure you change your windows to fit that. I kind of like the 1 to 2, then your window stays a little, you can do like the Zoom 6 and just do the 0, 0. 3 decimals on all your answers, except for when you have money. Money is 2 decimals. And the last one, I just kind of had you walk through each one of these again, starting with a certain amount. 6% interest, she deposits 500, 6%, it's in there for 5 years. So you want to know how much is accrued, accumulated. What is the result at the end? So all you need to do is throw this in your calculator. No y equals. Because you only have one variable, you have all your pieces here, your one variable is on the left-hand side. So throw this in your calculator, round to 2 decimals. My goal again to do this is it's kind of, you're using the same formula. You're seeing the part that you're changing, the n. You're seeing the n over and over, and you're seeing what's happening. The more I compound, the more I make. The difference between daily and continuously is very small. Very small. And let me just move this down. And continuously will yield you the best rate. Okay? Questions? Anybody confused?